Well, actually today I'm going to talk about secure millimeter wave communications that is developed by actually that their research is done by Shanghan and his team. So when I go to the introduction for the secure millimeter communications, today I discussed in Insights article by Shanghai and colleges, which propose site-based cooperative jamming scheme. That means we call SCJ, designed to enhance the security millimeter wave networks. This scheme addresses vulnerabilities in wireless communication channels by leveraging unique propagation characteristics. You know, this is well, in these days, wireless is the trending communication media that we use, and we have kind of attacks using wireless communication that with evil twin attacks, kind of uh, evil twin attacks, and kind to uh, uh, break the encryption and hashing algorithms in wireless communication and get the security key and do kind of various things. So when I go to move forward, overview of the SCJ is exploit difference between line of sight and non-line of sight signal, selective active jammers based on non-line of sight visibility and legitimate receivers. And aim is minimize interference of eavesdroppers, minimize the impact on legitimate communication. The SCJ scheme smartly activate jammers that are non-line of sight legitimate users but may remain line of sight to potential eavesdroppers. The approach strategically increase interference towards unauthorized listeners, significantly boosting the security performance. When move forward, uh, theoretical contribution utilize stochastic geometry. Stochastic geometry, so this is branch of mathematics used to analyze the random spatial patterns, and utilize sophistic geometry, that's we call PPP and PHPS. PP means position point process, and PHP is position hole process. Position point process means that's a mathematical model that randomly places points. Position hole process is kind of a advanced, that same process, but a kind of advanced. The key strength of the article is robust theoretical contribution. Authors to use sophisticated mathematical tools like position point process and position hole process accurately model complex network environment, showing clearly enhanced security performance through simulations. And when move forward, it's methodological limitations, idealized assumptions, perfect node locations knowledge over simplified antenna models, and real-world uncertainties, mobility, dynamic environments overlook. However, the notable limitations. The research assumes ideal conditions like perfect node positioning and does not realistically account for antenna imperfections or mobility. The factors could significantly impact practical effectiveness. When move forward, practical limitations concerns no detailed discussion on practical deployments. Actually, the issues is synchronizations, signaling overhead, and protocol integrations. Another crucial limitation is the absence of detailed discussions on practical limitations, critical aspects such as synchronization among jammers, signaling overhead, and integration into existing systems need further exploitations. Likewise, and finally, significance and future directions, valuable contributions to millimeter wave network security, SCJ schemes, complementary to traditional cryptographic methods, future research. They mentioned realistic validation, enhanced antenna models, and scenarios. Despite the limitations, SCJ significantly contributes security millimeter wave communications. Um, and how to it's practically approach these things. Conclusions, these are the conclusion: theoretically innovative but practically challenging, and call for realistic validation and addressing the implementations. So that's it. This is the reference, and thank you.